Hi guys, good evening all. Am I audible to all of you?
Yes, sir. Good evening, sir.
Fine. So, have anyone tried regarding the last session? Have anyone continued that one and got results without errors? Warnings are acceptable. Anyone tried?
Sir, I have tried, but some warnings will be created.
Warnings,
Warnings
amplification
for
factor greater than 1.4, that is acceptable. Any
but
other
errors,
warning?
errors. Sorry.
Okay. So errors. So okay, we'll try this. We'll try this time, and let's see how it goes. Okay. So I'm sharing my screen. So this is the frame. Last time we have stopped. Okay. So I'm continuing with that. Where the last class has discontinued, I'm continuing with that. So we have completed live load case here. Is my screen visible to all of you, right? All of you are seeing my screen, right?
Yes, sir. Yes, sir. Yes, sir.
Okay, fine.
Sir, also, last class I am absent. That 5.375 is the bay distance, sir.
Tributary. That we call
Yeah,
it as
tributary.
tributary. Yeah.
Yes, sir. Towards the main length side, length of the next column of
Yes.
imaginary.
Yes. Along the length. Along the length.
Okay, thank you, sir.
Yeah. So okay. Now I'm going with remaining loads. Load. Sorry. Load 5. Wind load case 1. So in our example last time we have seen. Where is that? Yes. Okay. Last time we have seen different different coefficients for walls and different coefficients for roof, and I have provided this sheet to you so that you can try. Already I have written in the cyclic manner. Okay. If you observe the bottom of the sheet in the wind coefficients tab, I have mentioned all these things in the cyclic manner. If you observe, suppose let us take case 1. Okay. Suppose let us take wind load case 1. So this is the net coefficient. Net coefficient means what can I tell? External plus or minus internal. That can be called as net coefficient. Okay. So this is the net coefficient last time we have got, right? So this net coefficient, suppose this 0.5 is acting towards the column. This 1.1 is acting away from the rafter. This 0.6 is acting away from the rafter, and this 0.4 quotient is acting away from the rafter. So that I have written all the coefficients in cyclic manner like this. Okay. Suppose let us take surface 1, surface 2, surface 3, surface 4. Okay. So like that I have written. If you observe here, 0.5 I have written here, 1.1. Okay. So just okay, fine. Okay. So I have written these quotients according to the stat sign convention. Okay, if you observe this thing, this is acting towards right. So generally for column we apply load, lateral load in x direction, right? Global x direction. So in global x direction towards right is positive, right? That is why I have taken 0.5 as positive. Anyway, here also it is positive. So you cannot find difference. But if you take this coefficient, this is minus 1.1, minus 1.1 according to the code. Why it has become minus 1.1? Minus indicates it this coefficient acting away from the rafter. Okay, that is why the code has produced negative sign here. But in order to give it in the stat, generally in which direction we apply wind load on the rafter? In y direction. So y is positive towards up, right? So y is positive towards up. So that is why I have given positive here. Though code value is negative, actually this is according to the code convention. In the stat, y is positive upwards, negative downwards, right? That is why I have given positive 1.1, and this also positive 0.6, and this is also for column we are applying wind loads along x direction, right? X is towards positive, towards right it is positive, right? That is why I have given 0.4. So all the things are plus here. Okay, if you take case 2, case 2 is nothing but reversal of case 1. Nothing but case 1 is flowing left to right wind, whereas case 2 is right to left. Okay, so in this case, if you observe here, it is 0.4 negative. Okay, negative means acting away from the column, away from the surface, according to the code. So anyway, in the stat also towards left it is negative, right? X direction towards left is negative. That is why I have given minus 0.4. And if you take these two values, if you observe these this direction, these are showing upwards. So y is always positive towards upwards, right? That is why I have given these two values positive. And if you observe again, it is negative. It is towards left. So that's why it is negative. Okay, so like that, I have derived all these coefficients in cyclic manner according to the case wise. So this is case 1, case 2, case 3, case 4, case 5, and 6 cases. Okay, this is the last case. So now I am applying this into the stat. Okay, so I think in the ASC design. Okay, just give me a minute. Someone is disturbing me. Yeah, fine. Okay, so if you observe this thing, last time we have taken in AISC the tributary is 7.5. Now how much it is? 5.375, right? So this is the tributary I'm changing here. So okay, why? Because how to apply wind load? Coefficient multiplied by tributary multiplied by wind pressure. Okay, wind pressure in our example it is 0.61. Last time we have got in the previous class, that is 0.61. The same thing I'm applying here. Okay, so that is 0.61 here. You can see. Okay, what are the units of 0.61? Wind pressure, it is in kilonewton per meter square. Okay, so we have to apply this as UDL. So in order to transform the aerial load into UDL, you have to multiply it with certain length parameter. That we are taking it as tributary here. Okay, this anyway we have to take coefficients from IS 875 part 3. Okay, So that is how I got this one. If you observe this one, this is getting this is how I got 0.5 multiplied by 5.375 multiplied by 0.61. This is the value I got here. Like that, I have derived this Excel sheet. Okay, so every row is multiplied by these 3 columns. Okay, like this. So I have provided a formula like that. So now I am applying wind load according to these cases. So before copying that one, what is the command we have to give here? Because where we have to apply load?
Member load.
Yes, because we are applying on segments 1, 2 and 5 to 22 and 3, 4. In the stat, simply these are called members. Okay, we know whether it is column or a beam according to our terminology, but stat does not know. It consider all as members. Okay, so that is why we have to apply this load on the members. That is why you have to give command as member load. Okay, after that, what you have copied, you have to simply paste that one here. So does anyone have any doubt here? Why I have done like this?
Sir,
Yes, tell me.
5 to 13 load के साथ ये
Yes, exactly. Yeah.
And the 14
Exactly.
to 22.
5 to 13. This is the last. I have copied it from AISC. That is why. Okay, 14 to 22. Right. Exactly. That is the valid point. Okay, so now I need to change here also, right? In the Excel sheet, if I change here, it is better. 5 to 13 and 14 to 22. So simply so now it is okay. So anyone following or not? I'm getting doubt. Yeah. So okay, thank you. So I have completed wind load case 1. Now I'm going to apply load 6, that is wind load case 2. Okay. Don't think what is this one. This is just a naming. Wind load case 1. That is simply I have given WL1. Whatever the name you want to give, you can give. There is no restriction in the start. That is your wish. Okay. Again, member load. Just I have to copy and paste the second case here. This is the second. This is the second case. And again, load 7, WL3, member load. I'm copying the third case. Load 8, WL4, Control C, sorry, member load. I'm just commenting these lines in order to make you comfortable, because if I remove these commented lines, it all get clumsy. You cannot differentiate between the load cases. That is why I'm just giving some commented lines here. load 9, wind load 5. Sorry, I think I forgot to give member load here, right? Yeah. And the last one, load 10, wind load 6. Okay, this is how the loads to be applied, and we are not applying temperature loads here. Why we are not applying temperature loads? We have discussed in the last class. If you have any doubt, please go through the recordings. Okay, and if you have any doubt, you can ask me. Okay, just simply outlining that one. We are not applying temperature load because in India there will not be any rapidly change in temperature. There is no rapid change in temperatures in India actually. Okay, but if you consider the countries like North America or cold countries, all these things, polar near to polar regions, or otherwise some countries away from the polar regions like West Indies, all these things. If you observe in the West Indies, the temperature may heavy, right? It is much heavier than normal room temperature. And if you observe the countries near to polar regions like North America, etc., these countries will have generally freezing temperatures. If that is the case, generally we need to go with temperature loads. Okay, in India there are no such cases, but if customer wants to add temperature load, generally we will not add. But if customer forces you to add temperature load, then what is the factor you have to apply is the same thing as dead load factor. Whatever the combination, so whatever the safety factor you are applying in the combination for dead load, the same safety factor you can apply it to the temperature load. That is the general case. But in most of the cases, no need to apply temperature load in India. Okay, because this example I am taking completely as per Indian code. Okay, last time we have applied temperature load. I think all of you are clear. Last time we have applied temperature load because I have done according to AISC design, right? So I'm continuing with this one.
Sir,
Yes, tell me.
sir, some textile mills
Huh?
have a temperature.
Where?
सर टेम्परेचर टेक्सटाइल मिल्स जो होती है सर उसमें टेम्परेचर हैवी रहता है उस कंडीशन में सर क्या करना चाहिए?
Sorry, I'm not getting you. I'm just getting echo from your voice.
Sir, for designing structure,
Okay.
textile mill.
Huh?
Textile mill.
Textile mills. Yeah.
Yes, sir. In this industries, higher temperature.
Yeah, actually, like some industries having boilers, or some industries will have. Yes, exactly. Textile mills and some furnaces, blast furnaces.
Yes, sir.
All these things, some industries will have. At that time, you have to apply temperature load. Okay, but how to apply temperature load is that you can apply the same thing as we have applied in AISC, but you may get doubt what is the safety factor we have to apply in the combination. That is the same thing. Suppose if you go through LSD combinations in IS 800, just let me show here. Okay, where it is? Yeah. So okay, there are no such temperature cases here. Okay. So if he has not mentioned, if you see this, okay, suppose this is the case. Okay. suppose here dead load factor is 1.2. Suppose, for example, I'm telling you, suppose here dead load factor is 1.2. He has not mentioned specifically temperature load combination here. You can take the same dead load factor for temperature, same safety factor for temperature load also.
Okay, sir.
Clear?
Okay, sir.
Okay. So next thing, what I have to do in my design, I have applied, if you see here, seismic loads I have applied according to IS 1893, and I have applied a roof dead load, mezzanine dead load. I have applied roof live load, mezzanine live load, and according wind loads. So what is the next step?
Combination of loads.
Yeah. Sorry.
Load combination, sir.
Yes, because any structure, okay, whether it is RCC or whether it is steel structure, we should not design it for primary load cases. That is the main thing I have told you in the previous classes. Okay, we should not design any structure for primary load cases. Okay, because all the loads will not act simultaneously at the same factor. Okay, some may act at the higher than expected, some may act at lower than expected, like that. Okay, so based on that, our code has provided some certain combinations here. Just I'm taking the load combinations from my file. How I have taken, I'll show you. Okay, already I have taken load combinations here. Just I'm taking it from the previous file. Now, how I got these load combinations? This is the concept. Okay, I have written because it will take time, right? That is why I have written previously all these combinations. So I'm putting them side by side. You can see left side there are partial safety factors or loads.
भाई के साथ कोई और सफेद रंग बंदा ना तो अकेले होता है ना एक बार ये बता थोड़ा बहुत रंग छोड़ दे
Sorry, someone is disturbing the class. Can you mute yourself? I cannot mute everyone. Okay, fine. What are the units here before applying the load? Yeah, it's in meter kilometer. Fine. So this load combination, suppose this is according to IS 800 table number 4 and limit state method combinations. Okay, this is the syntax. Generally, last time same syntax. Last time we have seen load com 101. I'm starting the case from 101. You can start from 201, 300, 46 or 56, whatever the number you can start. It's your wish. There are no such restrictions here. So just for my convenience, I have started the combination from 101. Because after 100 it is a round figure, right? I have taken like that. Okay, so this is the what is the first combination here. If you see 1.5 dead and 1.5 live load. Okay, this is accompanying live load. In the yesterday's class I have told you why I am not taking accompanying live load case. Generally, if you observe the point here, when the action of different live loads is simultaneously considered, the leading live load shall be considered to be the one causing the higher load effects in the member or section. Generally, we cannot differentiate which one is leading load, which one is accompanying load. We cannot differentiate like that. So that is why we are treating all the live loads as leading live loads. That is why I am taking the safety factor as the critical safety factor. Okay, so in 1.5 and 1.05, critical is 1.5. That is why I am taking here 1.5. Okay. So if you observe 1.5 is for dead load, 1.5 is for live load. This is the first combination. So what is 3 here? 3 is the dead load case number. If you go to 3, this is the dead load case number. So okay, for dead load, what is the factor here? It is 1.5. So that is why for load case 3, it is 1.5. And then for load case 4, what is the load case 4 here in our case? That is live load. So what is the factor for live load here? I have considered 1.5. That is why I have taken 4 space 1.5. Okay, this is just the name. Okay, you can give 1.5 DL plus 1.5 live load. This is just the name. Okay, whatever the syntax containing here, it is just the name. Okay, this is the main syntax you have to give. Okay, first one should be the load case number, and the next one should be the factor, safety factor, partial safety factor. Okay, again you have to give space and the next load case and partial safety factor for that load case. Like that you have to give. Okay, and the second combination, if you observe, dead load, live load, CL means crane live, I think here. If you observe here, crane load. So okay, so dead load, live load, crane load, wind load or earthquake load. Wind load and earthquake will not act simultaneously at a time. So either one may act at once, right? So either you have to consider wind load or you have to consider earthquake load. Like that, I have taken combinations here: 1.2 dead load, 1.2 live load, and 0.6. First one I am taking wind load. If you observe here, 1.2 dead, 1.2 live, 0.6 wind load case 1. Because we are having 6 load cases, okay, that is why this combination has repeated 6 times for each wind load case. Wind load case 1, 2, 3, 4, 5, 6. Okay, what is the only change between these 6 combinations? Only wind load case will change. If you observe here, what is the wind load case 1, load case number 5? It is 5, right? So that is why wind load case 1, load case 5, it is here. Okay, the next thing, it will not change. Only instead of 5, it will come 6 here, and then 7, 8, 9, and the last wind load case is we are having here 10. So with this 10 wind load cases have been completed. So okay, if wind load is over, what is the next combination we have to apply? With the same load factors, this 0.6 should be applied to seismic, because we have applied 0.6 for wind load case in our first priority, and then in the second priority we are applying 0.6 for earthquake load case. EL means earthquake load. Okay, so that is how. Okay, if you observe 3 1.2, 4 1.2, here also 3 1.2, 4 1.2, up to here it is same. So okay, what is the change between these two? 0.6 seismic comes instead of 0.6 wind. Okay, seismic, what is the seismic load case? We are applying seismic in load case 1 and load case 2. So that is why again this combination is repeated 2 times. Okay, like this all the combinations has to be derived. And the last combination, if you see here, 1 and 0.35, 1 and 0.35. Like that, I have derived all the combinations. So do you guys, any one of you having any doubt here?
No, sir.
Clear?
Clear, sir.
Okay. So if you are clear, then what is the next case? Actually, I have given you yesterday one reference file. According to the AISC design, one reference file I have given. Okay, and one Excel sheet I have given to you, and this partially completed stat file I have given for your trying. Okay, so if you go through all these things, you can expect what is the next step.
Analysis.
Yes, exactly. Because sorry, we have applied all the load cases. We have to perform analysis. What will happen if we give perform analysis command? Already I told. Perform analysis. What is meant by analysis actually? So calculation of properties for a given section, like shear force, bending moment, and load wise deflection. All these things will be calculated if you give perform analysis command only. Clear? Perform analysis. And then load list. So what is the purpose? Okay, just I'm explaining you each and every line. Whatever the line I'm using here, I'm going to explain you. So up to now, is it clear? Perform analysis, why I am giving here, is it clear to all of you?
Yes, sir.
Yeah. Yeah. So perform analysis will be given for calculating, simply I can say analyzing the section for the given loads. That is will be done by perform analysis command. So what is meant by analysis? Calculation of all the section properties, like not section properties exactly, analytical properties like shear force, bending moment, deflection, all these things. Okay, structural properties. So load list. So what is this load list command? So load list command, generally why we have to give load list command, which combinations or which loads you have to consider in the design. Okay, if you see here, we have given from load case 1 to load case 10 as primary load cases, and load case 101 to load case 134 as load combination cases. So there are different types of loads here. So which one you need to be considered in the design? So stack does not know directly, right? Which one it has to take in the design? It does not know it. It is just a program. Whatever the command you will give, it has to perform according to the command. Just that is the property of this program. That is the behavior of this program. So you have to give perfect program in order to get accurate results. So we have to design a structure for the load combinations only. We should not design the structure for primary load cases. Okay, so load combinations has started from load case 101 and it has ended with load case 134. So load list will be 101 to 134. For this one only you have to design like that, you are telling to the stat. Okay, so after the load list, what is the next thing?
Design parameters.
Yes. Design parameters. So design parameters. In the design parameters, I am going to take parameter 1. So, okay, this one need not to give 1. You can give 101, 1001, 1000, any number, 900 or 800, something, whatever the number you want to give, you can give. That is not the problem. So why you have to define parameter 1? Okay, suppose example I'm telling you, you are designing a steel structure by using conventional steel, and the second option, okay, just for your reference I'm telling you, the second option you are going with built up sections. Okay, actually in PEB generally we go with built up sections. So built up section is nothing but different plates will be combined or different plates will be connected to form web and flanges, like that. That is built up section in common terms. Okay, hot roll section will be directly molded in a mold. Okay, so you want to check which is economical. Generally PEB built up sections will be economical, but you want to check both the cases. For example, Okay, by using conventional steel like hot roll sections and by using built up steel. So in that case, this point will help you. Okay, so parameter one, in the parameter one, you can give built up section properties. Like in the parameter generally what I am giving here, first one, which code it has to design, code IS 800 2007 LST. This is the first parameter, first design parameter I'm giving. And the next thing, yield stress FYLD. Okay, yield stress. Suppose in my case it is 345 Newton per mm square. Why I have given 345,000? Because my units are in meter kilonewton. If you observe here, my units are in meter kilonewton. So 345 Newton per mm square or 345 MPa converted to 345 kilonewton per meter square. 345,000 kilonewton per meter square. So which thing you have to apply? Okay, for all members. Okay, for all you can give, or you can take MEMB members. Okay, this is the shortcut for member. Okay, member 1 to suppose 42, like this you can give. Okay, anything can be acceptable. You can give like this, or you can give simply all. Okay, for all visible sections you can give FYLD. Okay, okay, and FU, suppose okay, just I'm giving the sectional properties. And STP, FU means I think you know, FU ultimate. Okay, ultimate stress. This is yield stress, this is ultimate stress for my steel. Okay, this will be given by your company where you will work. Okay, whatever the steel, grade of steel, it depends on the grade of steel they are using. Okay, STP. STP, what is the command for STP? I think last time.
section.
Yeah, exactly. You are designing by using built up sections, or you are designing by using hot roll sections. Okay, if you give STP1, that is you are designing with hot roll sections. STP2 you are designing with built up sections. So I'm designing with built up sections in this one, STP2 all, and beam 1. So beam 1, why I am giving beam 1? Okay, I told you already, beam is a command which helps in providing the shear force or bending moment at every 12th portion of the actual length. Suppose in our example, if you take a beam length has 12 meters, okay, suppose I'm telling you, if your beam has 12 meters length, it will give you detail at every 1 meter, nothing but every 12th portion, 1 in 12th portion, it will give you details like shear force. What is the value of shear force at every 1 meter? What is the value of bending moment at every 1 meter? What is the value of deflection at every 1 meter? Like that. It has to perform analysis for every 1/12 of the section. That is beam 1. Okay, if you give 0, it will perform analysis for entire section as a one segment. Okay, that is beam 0. I'm going to perform, because I want accurate results, I need to perform at every small section, every possible smaller section. That is why I'm giving beam 1 all. And the last parameter, track 0. So what is track 0? Track 0 is nothing but, yes, any doubt?
STP2 all, STP not for IS code, IS 800 code.
Okay, let me check. Let me check.
Last we have run beam in this file. It will be error STP2.
Actually, sir, actually, it is in limit state, not in working state. Limit state parameter, it is there.
Yeah, yes.
LSD and WSD, if we select parameter LSD in graphical method, it will
Yeah.
show HTTP. But if we
Yes.
select working state, it will not show HTTP.
Yes, 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 yes. Just let me show all these things.
Okay, sir.
Okay, track. So what is the track here? Track generally it defines the state of output. Okay, whether you want to report the output at maximum detail level, that is track 2. You want the report the output at medium detail level, that is track 1. If you do not want the output at detailed level, that is track 0. Generally, it will not show any sort of disturbance in the design. It will not show. So this is okay. All these things I have mentioned in the parameter 1. So why I have defined parameter 1? So if I take parameter 2, it is second option. Okay, parameter 2. Okay, if you want to do second option with suppose let us take hot roll sections. Okay, so all these things will be come here, but these values will be changed, okay, depending on the section properties. Okay, what is the hot rolled steel yield value, what is the ultimate hot rolled steel value, and this STP will be 1, and the remaining these things will be different, the same. Okay, you can paste it here. That is why we are defining parameter 1 and parameter 2. If you want anything optional, if you does not require anything, you can comment it. Okay, that is why STAT has provided just a function like parameter 1. Okay, just how can I tell? This is like an artificial memory. Like all these things will be stored in a parameter 1. Okay, it is like just a runtime memory. Okay, these all things will be stored in this parameter. Okay, if you on this parameter only, then only they will be applicable to the program. And the next thing, what is the next thing we have to give?
Check code.
Sorry,
Column
what is
LS,
column? So what can we call?
Sir, LY, LZ.
buckling length.
Okay, untraced lengths or buckling lengths. Okay, so just you are seeing here beam numbers. So okay, so already I have shown in the last class what is the sorry, yeah, what is the effective length factor for this column? I'm just asking effective length factor for this column. I have shown you in the table, right?
One end fixed and pinned. It will be, I think, 2. It was, I think, 2, sir.
Yeah, exactly. KZ value will be 2. Okay, KZ value will be 2 for this column. Column number 1, 2, and 3, 4. Okay. Column number 1, 2, and 3, 4. KZ value will be 2. Then you will get doubt. Can I give like this? Can I give like this?
Sir, why KZ is 2?
Yes, sir.
Are we treating is it cantilever?
No, one end
No.
is pinned, another is fixed. No,
One end is pinned and another end is free.
fixed.
Fixed. Okay.
Okay, I think you are getting confusion here. Okay, just I am fixing here. Okay, this is the pinned end. I am fixing the connection here because this is called rigid frame. Okay, whatever the lateral force coming onto the frame, that has to be transferred by using rigid frame action only. Okay, it has to transform the moment from column to beam. Okay, so that is why it has to transform moment. Just I'm highlighting the moment here. This should be moment connection. Okay, this should be fixed. Okay, so one end is pinned, one end is fixed. Okay, someone will get this is not exactly fixed. Okay, translation is allowed because we are doing sway frames. Non-sway frames we are not doing here. Okay, we are doing sway frames, nothing but there will be some sort of sway. Okay, due to lateral loads like acting due to seismic or acting due to wind, all these causes there will be some sort of sway. Okay, that is why we are doing sway frames here. Though it is a fixed connection, it will allow some sort of sway. Nothing but this node will be displaced from original position to some sort of position other than this. Okay, so translation allowed, rotation is fixed. Can you go through the effective length factor table? Someone has asked it out. One end is pinned, and the other end translation allowed, rotation fixed. Rotation fixed means moment is not allowed to release. Okay, so what is the factor there? Just it will take time to search through the code book. Just I want to show in the Google just. This one. Thing. Can anyone found that one? Yeah. Oh, just okay, it is asking to save. Okay, fine. Leave it. Can you see my screen? Yes. Someone has asked a doubt, right? Can you see my screen?
Yes, sir.
Okay. Sorry. So in this case, we are talking about this case, right? Okay. We are talking about this case. Okay. If you observe here, this is pinned connection. Okay. Just they have mentioned wrong here. Actually, one end translation is restrained and rotation is free. Okay, just they have mentioned wrong here. Just I am correcting. Okay. This is not free at one end. Just I am talking about the base. At one end, translation not allowed, restrained, I can say. Okay. Translation restrained and rotation allowed because it is pinned, rotation free. Okay. And if you talk about the other end, translation is free. That is, we are doing sway frames. Sway is allowed. Okay. So translation is free. Rotation restraint. You can observe here rotation restraint. That is moment connection. Okay. So that is okay. Do you agree with me, guys? This case clear? Yeah. So what is the KZ value here? 2. That is the same thing I am taking. Still anyone have any doubt? If you observe code book, I think there is some mistake, right?
Sir, Sam in IS code 800. Page number 45. Please check.
Yeah. Okay. Fine. Yes. If you tell page numbers, then it is
45.
fine. Okay. Fine. Page number 25.
45. 45.
45. Yeah. Exactly. This is the case we are talking about. Fine. So, okay. Have you gone through this case? Is this the correct one they have mentioned? Is this the correct? Okay. Since the code has been prepared by a human, they can make some mistakes, right? Actually, what happened here, they both has to be reversed here. Okay. If you observe here, translation is free in the both cases. Translation means if you push the column, it will slide. Okay. Is it a stable structure? In both cases, if translation is allowed, okay, if you push a column, it will slide. Is it a stable? Just think practically. Just I'm letting you to think practically. Is it a stable? I think this is the mistake you have found in your BTech level only. You can find here. You can find just these both cases have been reversed. Okay, this restraint should be here. This free should be here. Okay, so translation restrained here, rotation allowed, that is free, rotation free. In the top, if you see, translation is free, nothing but sway allowed. Rotation is restrained because it is a fixed condition. It will not allow to it will not allow to release moment.
Yes.
That is restrained. Yes, fine. Agree with me?
Yes, sir.
Sorry, I'm getting some voice disturbance. Yes, tell me. This is not only for cantilever case. This is also applicable for this case also. That is 2. Okay, just I want to continue the class. Okay, still you can, still you have any doubt, you can ask me. Okay, so KZ2 for members 1, 2, 3, and 4. Is it the correct way I have to represent here? Is it the correct way? If it is not the correct way, you are thinking why it is not correct. What should I do in order to rectify my mistake? Just I have told you in the last class, what should I do in order to rectify my mistake? if it is not correct, if the line is not correct. So, okay, it is taking time to get answer from you. Just I'm telling you, this is entire column. Just I am drawing, as I'm giving dimension here. This 6.4 meter is entire column. This is the one column from bottom to top. Okay, but in order to give mezzanine, you have segmented this one, right? In order to give mezzanine node, in order to give mezzanine node, you have segmented this column into two number of parts. Okay, then you cannot apply directly KZ factor. You have to give length directly. Okay, if you have only single member like these mezzanine columns, only single members 25, 26, 27, 28. If you observe all these things 29, 30, 31, 32, all these are single members. So in that case, you can give KZ value 1, but this is not the single member. Okay, the entire column has divided into two number of parts. You cannot give KZ value directly. So what you have to give? You have to give LZ value. Agree with me?
Yes, twice length.
Yes,
Length.
exactly. So KZ is 2, length is 6.4. So we have something, just let me open new notepad. So L is nominal length. Okay, KZ is effective length factor. So what is the LZ? I have studied all these things. Effective length KZ is equals to, effective length LZ is equals to KZ into nominal length. This is the one we are learning from the BTech stage or BE stage or degree stage, right? So this effective length factor should be multiplied with total length of the member, that is 6.4. So 6.4 into 2, that is 12.8 I have to give. So this is the way I have to give. Okay, but there is also another way. I'm telling you. LZ, sorry, small letters. LZ 6.4, member 1 to 4, and KZ you can apply here. KZ 2, member 1 to 4. This is also acceptable. Okay, if you find difficulty in multiplying this load effective length factor into length, if you find difficult, you can give like this. LZ is 6.4, and then after that command, if you provide KZ in the design, automatically it will take LZ as 12.8. Okay, this will be multiplied with this. Okay, so like this also you can provide. Different ways I am telling you. Anyway, you can take. Okay, so what is the LY? If you go through our section, cross section, this is full height block wall in our case. So we have segmented one node here. In order to get the mezzanine beam, we have segmented one node here. Actually, this is having full length unsupported. Block wall is leaning on the column. Okay. Actually, block wall is taking support from the column. It is not providing any support to the column. But in this case, if you have guts, okay, some 3 meter block wall and above sheeting, if your case is there, okay, there will be some secondary members to support sheeting, right? We can call them as guts. Secondary members to support sheeting as sidewall sheeting as guts, we can call. Okay, so those guts will provide some sort of support to the column. Okay. But in our example, we do not have any guts over here. So there is no support to the column. Okay. So in that case, what we have to do? If you have again segmented one into number of parts, if you have member 1 here, Okay, if you have again member 1 into some number of parts segments, in that case you have to give Ly, but in